Dear Vasily, dear Despina, members of the Aegis Athena Lab, fellow archaeologists, GIS experts, I'm Υiannis Lolos, as you heard, and on behalf of my co-presenter, Spiros Mousouris, who's going to take the podium soon, and Christina Giannakoula, as well as of all the participants in this project, I would like to thank you for inviting me to present, inviting us to present our work here. The title of the presentation is Methodology and Challenges in Geovisualizing Excavation Data, the case of Sikyon, and the underlying work was implemented thanks to a generous support from the 1984 Foundation. We will first present to you the aim of the project, and then we'll first present to you the aim of the project and problems we faced and how we decided to solve them. Then briefly give you some facts about the excavation itself, and then we will present the geovisualization project on a conceptual, operational, and implementation level, as well as general guidelines about creating similar user interfaces. The recent excavations of the Archaeological Society of Athens at Sikyon from 2013 to 2020 around the agora of the city brought to light structures of different periods and purpose and recovered a score of artifacts. Visualizing the results of this excavation posed great challenges. So what we will present here is the methodology that we followed to design and develop a web GIS that geovisualizes different levels of granularity for excavation data. We describe the steps, challenges, and tools in an effort not only to share the knowledge gathered from Sikyon excavation, but also to define general guidelines applicable to other excavations as well. So the aim is to raise discussion about geovisualization processes based on archaeological data. So some facts about the recent excavations. The recently excavated trenches cover a surface area of more than 2,000 square meters. It was an open area excavation, single context recording. So by context, well, we all know what it is, but just in case there's a non-archaeologist among us, we mean each action that leaves a trace in the stratification of an archaeological site, be it anthropogenic or a natural event. These actions can leave a positive trace, resulting in deposits of soil and other material and in structures, or a negative trace, in which case we call them cuts, as they cut into other contexts. We recorded over 1,100 contexts in the course of the excavation. So to the north, so the two areas that we targeted, the northwest of the agora and the southeast of the agora, these two areas. To the northwest of the agora, we brought to light a small temple that you see. Sorry. I'm talking about the southeast area of the excavation, where we, as I said, we excavated 2 rooms of the south store and were able to confirm this is one of the rooms, confirm its dating to the early 3rd century BC, part of a second store right here, one island of Doric order, which was built in the second half of the 1st or early 2nd century CE, and a large industrial complex with 3 main chronological phases. The first in the second half of the 1st century of the first half of the 2nd century CE, the second in the second half of the 4th century CE, and the third and last one in the 6th and 7th century CE. So here is one of the rooms of the store, of the south store that we excavated. This is the excavation of the northern end of the southeast store here. Again, that oblong trench that you see dates from Orlando's time. So it's not us. Don't think we're chasing walls. It's one of the bothering things here in our excavations. The visitors see this and then see And then thinks, what are these guys doing? And here is the workshops, the industrial area with different phases. Among the installations that were excavated, we can single out 5 ceramic kilns, 1 basin, 1 treading floor, and 1 and 2 stone platforms. So that's it, and I'm giving Spiros is going to continue. So we had a lot of monuments and structures exposed, hundreds of thousands of objects, and well.
Thank you.
Okay, so as you saw, the nature of the excavation posed some geovisualization challenges. First of all, it has a number of structures and contexts from different chronological periods containing findings from different categories. So the first challenge was the organization of the level of granularity, and another challenge was the geospatial organization of the structures and contexts, since their overlapping makes it difficult to study them and understand their order. After examining user interfaces of similar WebGIS applications that geovisualize excavations, at least to the best of our knowledge, we observed that the majority of them usually presents general facts about the excavation and the most important findings, and unfortunately, the relationships, hierarchies, and categories of the data are not presented. There seems to be a lack of common knowledge, common logic, and guidelines for those kind of WebGIS applications. To overcome the visualization challenges, we needed an analysis to essentially guide us in order to create and organize a WebGIS application. We considered the general archaeological practices and also zoomed in to the specificities of the Sikyon excavation. To achieve general applicability, we analyzed the designing needs based on commonly accepted guidelines in order to avoid reinventing the wheel. So we combined analysis on conceptual, operational, and implementation level. Now, please note that all the following principles and guidelines have, of course, Sikyon as a starting point, but can be applicable to similar applications that also geovisualize excavations. First of all, the conceptual level, it defines the goals, the users, and the results of the application. There are 3 general goals for geovisualization here: information searching, fact verification, and the availability of findings. In order to analyze those goals, we followed the fundamental principles of analytical design. First of all, of course, we categorize our data based on the nature of the findings. And we use this geospatial and structural hierarchy. Simply put, we have buildings that contain parts, and then those parts contain contexts. Then we correlate and compare our data in order to contextualize them. We achieve that by organizing the interface according to the categorization I just explained. The next step is to define the question that the application needs to answer. For Sikyon, we wanted a searching functionality based on the categorization and to show the archaeological order of overlapping contexts. Then we define the users. Our application is primarily addressed to archaeologists and experts and researchers. And then we have to reduce the complexity of the whole application in order to avoid a cluttered interface. We used visuals, patterns, and we broke the navigation of the application into steps to achieve that. Now, for the operational level analysis contains the function needed to achieve the goals described. For the case of Sikyon, we have 3 functions: examination of the archaeological data, their digitization, and their definition of their relationships. So, continuing with operational level analysis, after examining the primary archaeological data that came from the excavation, we took advantage of the database structure that came from the excavation, and we removed unnecessary data. Then we decided on the final structure of the database and how the database tables are interconnected based on geospatial queries. Simply put, what contexts intersect or includes other contexts. And in this phase also, a first draft of the user interface was created after having contexts as the smallest unit of the structural hierarchy. For data digitization, georeferencing is important, so data can be later added in the database. Polygons were used for the excavation context. Each context was located on an orthophoto map, and a polygon was created to be connected to the database later. The shape of the polygons were based on top plans and sketches created by archaeologists. Now, for the final level of analysis, the implementation level, this is the level where practical decisions must be made in order to actually implement the WebGIS application. PostgreSQL database was used here, no surprise, with PostGIS extension to support geospatial queries. Also, GeoServer was used in order to serve geospatial data to the interface, and Node.js server was used to handle the complexity of the queries. We used the React.js framework for creating interactive interfaces. Now, about the creation of the interactive map, a key factor to decide the JavaScript library to be used was the problem of overlapping elements. We decided to use the principles of the space-time cube pattern to show contexts in archaeological order above the ground, highlighting their continuity, order, and shape. So we decided to use the Mapbox library because of its ease of use and plethora functions. You can see here different phases of the interface as it evolves. Let me now switch to a browser in order to present to you the WebGIS information live. I will be brave here. I will switch to a browser. I don't know if. I don't know if the participants online are.
We are okay.
Oh, okay. Okay, so you can see here all the buildings of the excavation on the map. There are two main ways you can navigate on the app. You can click anywhere there are excavation buildings or contexts. So, for example, I'm gonna zoom here, and I'm gonna randomly click here. So a marker appears, and a window shows all buildings and contexts intersecting with the point of the place that I just clicked. We translated geospatial and structural categorization into the interface. So buildings contain parts, and then parts contain contexts. You can click any of those and get more information. For example, I'm going to click on this building, and I'm going to get information about the description and excavation seasons. And I'm going to go back to my list here. This is how we broke the navigation into steps, as I already explained, creating a scalable solution where more steps can be added or removed, and more data can be added on a specific step. To solve the issue of overlapping contexts, we project their 3D representation in order based on the elevation. You can click expand for the contexts. And I can hold down the control button, and I can move around with my mouse. And this is how you can understand their continuity, their order, and their shape. I can hover the mouse over each and every one of them. I get a little pop-up there showing me some data about its content, and I can click remove all, and I can go back to the map and keep on studying. So the second way to navigate is the search bar. You can combine any of those categories here, either buildings, ceramics, or periods. I will select.
Spiro, you could open one of these contexts maybe to show, or are you going to do that later?
Yes, for example, I can click this context here.
And then
the map will zoom there automatically, and I get more information about the context, namely its description, data about the pottery, and data about its inventory and other findings. And then I can click here and go back to my list again. And about the searching functionality, I will, for the sake of example, I will choose find ceramics. I will click search. And now it will search all the contexts that contain fine ceramics. Obviously, please notice here that again, I'm getting the same structure. I have buildings that contain parts, contain contexts. I can click any of those and see which parts and then which contexts contain, which parts contain which contexts. I can then again click expand in order to see their order and shape, and I can remove them. And I can close that window. Observe that there are two windows containing information, one for the point that I previously clicked. It still holds its information here, and another one that holds the search results also holds its information unless you change the filters of the search. So you can, this allows you to study and switch between windows in order to keep on studying different parts of the same excavation. The last main feature I want to present is that every part of the excavation is linked to a specific unique URL that you can share, bookmark, or use as a reference. So when revisited, it will automatically zoom in the specific feature and it will automatically open the window with that contains data for that specific feature. So for example, if I refresh, you can see here that there's a specific URL with the number of the context. So if I refresh here, it will automatically zoom and it will automatically open the window containing information about a specific context. So to conclude, we present to you today general guidelines to organize and geovisualize excavation data with increasing granularity. Those guidelines create scalable solutions that we hope to be the starting point for discussing and innovating similar interfaces. For the next steps of our project, we plan to insert data about coins, archaeobotanical and zooarchaeological remains found in the excavation, and we will redevelop the search form to be more advanced, and we will also plan to have downloadable content as soon as we ensure licenses and copyrights for the data. Feel free to contact us. Thank you very much for your time. On behalf of all the creators, also Christina Giannakoula, GIS expert and archaeologist, thank you very much for your time.